Hey everybody, welcome to the stream. Today we are going to be talking about concurrent mode, React concurrent mode. So this is a new mode that has been on its way for a long time. The team actually announced it back in like mid 2018, and it was originally targeted to release in, I think it was Q2 2019, and it is currently January 2020. So they missed that mark a little bit, but even though it is experimental right now, they've been building the new Facebook application with this. And so they've been going through all the kinks. I would expect, I have no idea, I have no insider information or anything, but I would expect that this should be released pretty much any day now. But today we're going to talk about what it is. So React concurrent mode, it's the new way that React renders components. And the big difference is that it uses interruptible rendering versus blocking rendering. So as it says in the docs, these are the React docs, as it says in the docs, the best way to think about it is by thinking about version control, right? So when you have a file and you're on a team and one person wants to make a change to that file and another person wants to make another change, if you do not have version control, then you only have kind of one path. One person can work on that file and make changes at a time. Otherwise, you get a bunch of conflicts and you overwrite changes and everything, and it does not work. And so you have to have that one person working on one file. And the way to think about the interruptible rendering, which is what concurrent mode brings to the table, is branches. Source control branches, version control branches, where you have that kind of mainline branch that represents the mainline rendering that React is trying to figure out exactly what needs to be rendered and actually going through and rendering it. But then if there is work that needs to come into play or there's something that has to interrupt that rendering process, it can actually interrupt right in the middle of that work and kind of create a new branch, figure out what needs to happen in that new branch, and then switch to that new branch immediately if you want to, right? And so by taking this approach, it allows you to interrupt that rendering. What would previously be blocking rendering? So the couple of examples that I'm going to show in a minute, you've got a lot of CPU intensive activity, right? And today, without concurrent mode, before concurrent mode, React would have to finish rendering all of that stuff out and then in the next cycle say, okay, I'm done with that, now what? And then figure out that and render that out and so on and so on. Whereas right now, if you have with concurrent mode, when you have that high CPU or whatever, when you're trying to figure something out, React can actually stop in the middle and say, well, hold on, I got some user input here. And that is more important than anything else I'm doing. So let's evaluate that user input, see what I need to do there, and then possibly go back to what I was doing before, or possibly reject it, abort it, whatever, right? So that's the idea of interruptible rendering. So how do we adopt concurrent mode? Actually, it also has, or as a side effect or as a benefit of this interruptible rendering, you've got a couple of different things that you can do. So the first thing is suspense. So suspense is, as you can see here in this example, it's a component. And this example shows what you've been able to do for a long time now. So React 16.6, which I think was like mid 2018, actually added a component named suspense. And it allowed you to lazy load components, right? So here you create kind of, basically ends up being a virtual component that allows you to use it as a regular component in your page, wrap it as a suspense, and only when you actually evaluate this component will it actually go and download or import that component's data. Right? It'll actually go and download that component. So this allowed you to do lazy loading and code splitting. This was very crucial for code splitting, right? So tools like Webpack could go through and say, okay, you're bringing this in with an import. That means I will keep it separate from the main package. And then whenever you want to bring it in, whenever you reference it, that's what lazy does, only when you reference it will I actually evaluate this and download that file and load it up and everything. Now, the suspense component that's been available is the thing that is aware of that. And it says, while I'm waiting for that to download and render and evaluate and all of that, the component's not ready to actually use yet, right? So I'm going to wrap that into suspense, and while all of that is happening, I'm going to render this fallback. And the fallback in this case is a spinner, it's a loading message, it's whatever React data or React component you want to show. And this fallback will be displayed until that component is done loading. This was the only scenario that the suspense component has supported up until this point. So what's new here is suspense for data fetching, which I'll show in a couple minutes. We also have a couple other things, the suspense list, which I'll show in a little bit, and then also the ability to use deferred values. So this is another API that is a hook. So if you're still using class-based components, unfortunately, you won't be able to take advantage of these hooks. But this allows you to kind of have two different values, right? So a text value in this example, and then a deferred text value. So if you're doing something that is very slow, some slow operation, you can allow that value to kind of lag behind while keeping the user input and the user experience very kind of speedy and performant. So let's get into adopting concurrent mode. So the way to adopt concurrent mode is, where is it? Let's see, adopting concurrent mode. So because this is an experimental feature, you will need the latest experimental version. So when you install your packages, you use that experimental tag here. If we jump to the npm package repository here, we can see the latest version of this tag is F4243. So these, all of these experimental releases, they use hashes, not semver, right? So you can't count on these being incremented or anything, anything predictable. You just got to kind of look at what is the latest one. So you can install experimental and also React DOM. So you need React and React DOM. And then you enable it by changing your render function. So this used to be the beginning of your application, your initial render function. And instead of saying render your app component into a target element, you are instead creating root. You're calling React DOM create root. And you're creating a root element to which you will render your component here. So let's see that in action. So I have got this demo application that I've made. It's on Code Sandbox. So this URL will be available for you if you want to follow along with me. You can just go to this URL. I'm in fact going to fork this as a sandbox. And so now you can see this is my application. I've got a couple of different demos. I've got two tabs, two pages here. They are my slow input demo and the profile input demo. And here we can see kind of the old version of Suspense using React Lazy just to kind of dynamically load these components as I need them. And here's my example of Suspense. I've got a little loading component that you can see. You see when I move back and forth here, that's my loading component. And then we'll look at, and then let's go ahead and enable concurrent mode. So the first thing we need to do, again, is go and grab that experimental, the latest version of React. So in Code Sandbox, you do it here. I already have this version, 16.12 of React, and so I'm going to go into this drop down, and I am going to find that version that we saw before, which is not F6, it is F4. And then do the same thing with React DOM. Ooh, I don't like this UI. Be very careful. All right, F4. There we go. I'm going to leave the types alone because they don't have any new versions of those. I'll just use those. And in fact, these new types, or these types actually have some of the type definitions for the new API. So we'll get full type support. So I will, let me see, refresh just to make sure everything's transpiled. Yeah, get those. Okay, cool. So now I'll come over here and I can actually just copy and paste this. Right, so this is my old one, my existing one, and I can use this new one. So I can comment that out, use this new one instead. Now, in fact, there are two different modes of concurrent mode, right? So concurrent mode is a brand new rendering engine. And because it's effectively a rewrite and changes a lot of internals, there are a couple of things, 3 things in particular, that you can see right here that flat out are not supported. And then the things that are supported, you may find out, especially since this is an early version of the API and the feature, you might find out they kind of act a little bit weird. So to help you kind of migrate over, the team has allowed 2 different modes. They've created 2 different modes, a blocking mode and a concurrent mode. So this blocking mode you get by saying create blocking root, versus create root. And so this allows you to kind of opt into a subset of the concurrent mode features, right? So you can start playing around with concurrent mode. You can start seeing if your current code is how well it plays with concurrent mode before like fully opting in. And so you can read more about that on this page. But just note that neither of these modes support these 3 things: string refs, legacy context, and the find DOM node API. So those are not supported at all. So I can say create root or create blocking root. Those are my 2 options. For these demos, it really doesn't make a difference which one I choose. Okay, so now let's jump over. Actually, before I do this, let me show the app in action. So my first demo is this slow input demo. So this demo is I type something in this text box, and then below it, I render it 5,000 times. Let me show you the code for this. Very simple, very straightforward, right? So as I change the value of the text up here, it goes and it repeats it. This is actually doing 10,000 times. And so now as I type, you can hear me typing, but nothing's happening, right? There we go. And so finally it catches up. So this is an example of the fact that I'm rendering this 10,000 times takes a long time to render. And in the meantime, with each keystroke, React is basically ignoring that, right? And it's just waiting until it's all done, and then finally everything catches up. And that results in a kind of poor user experience. So, right, ideally I would say when I type a key, I get more or less immediate feedback, right? So this is kind of the feedback that I would expect as I type 60 words a minute or 80 words a minute, right? So let's go ahead and go back to, so that's with the legacy mode, the existing mode. Let's enable concurrent mode. So we'll enable concurrent mode, we'll refresh, we'll go back to that demo. So now let me type again. Still kind of weird, still kind of bad, right? So just by enabling concurrent mode doesn't necessarily fix this. It does, it's a little better. But now, if we go back here, let me go back and bump this down to, say, 5,000 times and maybe see it's a little bit better. Okay. So let's see how we can leverage concurrent mode here. So we can't really tell, I know it's not that obvious, but already we do have a little bit of a performance benefit. We have a little bit better kind of reactivity and a little bit better UX because concurrent mode is actually able to go and kind of render this value. And notice that I've entered some text and keep that text box a little bit more up to date. As we can see, I'm rendering 5,000 times. That's going to take CPU power, right? That's going to take a while no matter what mode I'm using. So there's no way around that, right? There are some things where you should just optimize your app. But concurrent mode can help you a little bit. So what we can do here, though, is we can take advantage of one of the options that concurrent mode enables, which is the deferred value. So we'll take a look at this. I'm just going to copy this. So this is how you use it. I'm going to import that deferred value, and then we'll talk about what's going on here. So now I'm using a hook that says use deferred value. I'm pointing to the text. That's this state right here. Right? So basically I'm wrapping that with a deferred value. And then I'm giving it a timeout, which indicates how long we should wait before showing the next state, or how long this can lag behind. And so we can see here that value is the thing actually being passed to repeat text. So in other words, we're saying that this component below here right? So now we can see that now my input is a whole lot faster. Again, it's not immediate, right? It's not like I press a key and it is immediately rendered. There still is some lag because my computer still is doing some work. There's no way around that. But we can start to see that separation of React is making sure that this kind of high priority interaction, the UX, the input field, is being updated as quickly as possible and letting the rendering fall behind. What we also saw here is this part over here. We're seeing the opacity changed, right? So the second kind of half of this component is checking to see if the value is stale, meaning is this value lagging behind? Is value different than text? So before we introduced this, value and text were always exactly the same thing. But now that we have we're using use deferred value, this value can actually be different. It will be different, as we saw. When that's the case, I'm setting the opacity of the div to 70% so we can actually see. So if I delete this and do it again, as I type, watch the text below, and we can see when it's out of sync, it'll be gray, or it'll have lower opacity. Right, so it's gray, 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 and then finally full opacity. So we're still rendering, right? That's the important thing here, is that the component is still rendering. We're just allowing this value to lag behind. So that's pretty interesting. So that's the use deferred value, which is now possible because of concurrent mode. Now let's jump back and look at the other scenario. This is suspense for data fetching. Quite honestly, when I first started reading this page, there's a lot here. And the way that you use it is kind of not that obvious. They say like, well, let's look at this resource.user.read, and there's a different API. It talks about APIs, the new relay APIs, and a whole bunch of stuff that's frankly has nothing to do with suspense. So forget about this. This is the page where you should go and read, but let me just give you the demo. So I'll show you my current component. That is this user profile, right? So here's the component on the left, and I'll kind of scroll through and walk through what it's doing, but I'll demo it first. So I've got a list of users. This list was loaded via Ajax when I first loaded the component, right? So if I switch back, load it again, you can see we got that loading until it's loaded, and then I choose one, and when I choose one, it goes and retrieves that user's information with 3 different Ajax requests. So that is all happening here with this use effect. So whenever the user ID changes, go and reset it, and then query individually, independently. So I've got the user details, post, and photo albums, right? User details, post, and photo albums. So I'm retrieving each of these things individually with individual Ajax requests. If I jump over to my API, I can see I've got my get user details, get user post, get photo albums. These are the 3 things I'm calling. In here, I've set some delays here. So these are actually, if I scroll down, these are actual fetch calls. They're going out on the internet. They're actual Ajax calls to this JSON placeholder.typecode.com. So this is all kind of dummy data that is coming from there. And on top of that, I'm introducing a delay, a wait, right? So this is kind of custom code that I've written that basically makes sure that these things come out of order. So we make sure that we get the user details first, because that's a 1-second delay. Then the photo albums should come next because they're on a 2-second delay. And then finally, really, really slow are all of the user posts. That's a 4-second delay. So that happens for each time that I choose a user, right? We've got the details back, photos, and posts. What if I didn't want that, right? So when we're talking about suspense for data fetching, this allows you to kind of simplify and control how this page is displayed. So I can say, I don't want to show anything until at least I have the details, right? I don't want to show 3 spinners. I want to show maybe 2, maybe a spinner for the photos and the posts. But I don't want to show anything until I have at least the user details. And then maybe I'll show everything, right? I want to be able to control that. So there's a couple of things we'll need to do. If we look at how this is currently implemented, right now for each of these things, they start out as null, right? So when the component initially loads, each of these is null. As I change the users, I first set them to null and then reload them. So at any given time, the user details object, the post object could be null, the photo object could be null, and for as long as it's null, I'm actually just showing this loading component here. So that's where we're seeing all of these spinners. I've got that manually. So what I really want to do is wrap each of these in a suspense and say that my fallback is this loading. So there's that. And now I want to get rid of this. This is going to blow up. See, you can see on the right, as soon as I did this, this is going to blow up. It's blowing up because it's trying to render a null value. So regardless of the fact that I wrap this in a suspense, I'm still passing in a null value. I'm still going to try and read from that value. It's going to throw an exception. So just because it's throwing an exception does not cause suspense to do the fallback. The way that you implement, or the API that Suspense understands for, oh, hold on, let me go full screen. The API that Suspense understands, let me go to this component, is actually throwing, so if user equals null, throw a promise. So this is actually the kind of API, or the way that Suspense knows whether or not to show the fallback. So if you throw a promise, not return a promise, but throw a promise, that indicates to Suspense that you're not ready yet, right? So now if I save, now if I go back to my demo, it'll work. See, this is kind of underwhelming because it looks exactly how it did before, but what I've shown is that now Suspense is actually handling this fallback, right? So I can go and I can refactor all of these to use Suspense. Do the same thing here, wrap the photo albums with, wrap the photo albums with Suspense, and then I have to go and update those components as well, the posts and the photos. So let me just go copy this line. If posts is null, and if albums is null, right? So if any of these things is null, just throw a promise that says, hey, I'm not ready to render yet. I'll let you know when I am. So now if I save this, everything should work. So now we're all set up. So now we can start controlling when and how these things are rendered. So I can now wrap this entire thing in a suspense. Where is? Here we go. I can wrap this entire session in a suspense. But what I really want to do here is use this other component. Let me go back to the API reference. I want to wrap these things in a suspense list. So what suspense list will do will help me coordinate many components that can suspend by orchestrating the order in which these components are revealed to the user. This is where I can really control and say, hey, don't render anything until I have everything, for example, or render them in this order or something like that, right? So if I go in this, if I go use this suspense list, change suspense, where are we going? To suspense list. We don't need a fallback because the fallbacks, the loadings, are happening inside here. And of course we have to import this from React. Just by doing that, using the default values, nothing has really changed. But I have two options that I can change. It supports two props: reveal order and tail. So by default, suspense list will show all fallbacks in the list. And then collapse shows only the next fallback. Hidden doesn't show any unloaded items. So let's take a look at those. Let's say tail, collapsed, or hidden. So we'll say tail equals collapsed. How does that look? Reveal order. Let's say together. So now we're saying everything needs to be displayed together. And why is this not happy? Property of tail and collapsed. Oh, okay. Let's start with reveal order. We'll look at reveal order. We move this inside of the div here. So now we see all of those different spinners, but we wait until all of them are downloaded before we show any of them, right? So we still see all of the spinners. It looks like all of them are loading, but we know now in the back that because we're pretty predictable, right? This loads in 1 second, this loads in 3 seconds, this is 4 seconds. We know that the details has already loaded, the photos have probably loaded, and then finally the post load, and then everything can show. Or we can say reveal order. What are the options here? Go back here. Reveal order forwards, backwards, or together. So let's see what backwards is. So backwards is it's essentially the same thing, right? Because backwards would basically start at the bottom and go up, and it would get stuck here. It's still waiting for post. So let's see what's forwards. What happens when forwards? So now when we say forwards, now we're saying, okay, the details is the first one, and it is actually the data that comes back first. So go ahead and reveal it, right? Go ahead and render that. Don't wait at all. So render that as soon as I get it. Then photos is the next one. Then post is the last one. So just go ahead and basically render them in order. This is where tail comes into play. So what happens with the other ones? Are we collapsing them, or are we hiding them? Let's do the backwards. So here we're seeing that we're actually not going to render anything, right? So when we say tail is hidden and we're loading backwards, we're waiting for everything to load, and in the meantime, nothing is being shown, as opposed to, what was the other one? Collapsed, I believe. So let me update that. So now we're working backwards, and everything else is collapsed until everything comes into play, right? And we can go to forwards again, collapsed. Let's reload this. So that's actually what I want to show, right? That's kind of the way that I want my component to work right now, my experience to work, is I'm going to reveal them in forwards order, meaning I want to show the first one that I requested, the first one that I'm displaying here, I want to show it in that order. So go ahead and show this as soon as I get it, and then wait for these and reveal them in forward loading order as we get them. In the meantime, collapse everything else, right? So we can say that as, load this again. Now I've got this, show my details immediately, and then allow these guys to kind of come in as they are requested and as they're loaded. So using this suspense list component, I can kind of control how and when all of my data is being rendered as I'm waiting for that data to be fetched. So that is the overview of the concurrent mode API. There is one final hook. There's one final API, which is use transition, which is very interesting. I'm going to hold off on this. I'll show it in a future episode, mostly because I'm not entirely sure. I haven't been able to get it to work yet, quite frankly. I'm not sure if the API is in flux, or there are experimental branch bugs in there or something. But this is also something to be looking at as the API is released and gets into a more stable state. This allows you to basically have a hook to watch the value, or wrap a value, some behavior, and wait until that behavior is complete, that function is complete, before actually showing your the component that you want to show in your suspense. So basically, as long as that action is pending, don't actually render that suspended component. Just show this message in this example, or a component or something instead. So it's a way to kind of control your experience. So like I said, I can get in that into a future video. But for now, that is concurrent mode, React concurrent mode. Go ahead and check it out, play around with it, because it's coming. It's coming soon. I don't know when, but it's coming. Thanks for watching, and I hope you learned a lot. Have a good time. Happy coding.